Hello, and welcome to our discussion, Chapter 4. We're going to talk about designing studies and sampling surveys. This is the first section of our work. So we're going to talk about 6 different items. The idea of a sample survey, sample versus population, how to sample badly, how to sample well with random sampling, other sampling methods, inference for sampling, and then what can go wrong in sampling surveys. All right, so let's create some definitions. So a population in a statistical study is the entire group of individuals about which we want information. So typically we're not going to survey the entire population. We're going to survey a sample and then extrapolate or create inferences based on that sample. So sample is part of the population from which we actually collect information. We're going to use information from the sample to draw conclusions about the entire population. All right, so here is some classwork we're going to do together. So we're going to identify the population and the sample in each of the following examples. A furniture maker buys hardwood in batches. The supplier is supposed to dry the wood before shipping. The furniture maker chooses 5 pieces of wood from each batch and then test their moisture content. Second is each week the Gallup poll questions a sample of 1,500 adult U.S. residents to determine the national opinion on a variety of issues. All right, so first we're going to identify the sample and then we're going to identify the population. So the furniture maker buys hardwood in batches. Population is going to be all of the hardwood in batches. The sample is going to be the 5 pieces of wood that we sample or take from all of the hardwood. Second, population is going to be all U.S. residents, and then the sample is going to be the 1,500 people that were surveyed as part of the Gallup poll. All right, so that brings us, so that's just a quick explanation of population and sample. Again, population, all of the people that we want to understand in some way. All the individuals, and then this sample is a fraction or portion of that set of individuals which we're going to survey or poll or find information about to use to extrapolate about the entire population. So this brings us to classwork 4.1.1. We're going to identify the population sample in each of the following examples. So you can copy this down and pause and copy it down, and I'm going to move on. There's no need to copy down the entire question, just provide me with the answer. Okay, so how to sample badly. All right. So let's talk about how to sample badly. Okay, right. So these are different ways to mess up your sample or the data that you're getting. Convenience sample or convenience sampling is where you choose individuals who are easiest to reach. So this sample creates a possibility for bias because we choose people who may fit into a certain category that are more available, that may slant the results of the survey. And we found this especially in the 2016 election, where people who were easy to get a hold of were sampled, showed that Hillary Clinton had a pretty sizable advantage. But what didn't happen was the survey of the people who were challenging to get a hold of. And the results from those surveys, once they were taken, showed that Clinton's advantage was not so significant. So it's important to be able to sample across populations and randomly, not just people who are available. All right, second is, and sometimes that may be difficult to do, by the way. Second is bias. Design of a statistical study shows bias if it systematically favors certain outcomes. So we might say that the SAT results show some bias just because of the way it's formatted. So we have to be careful about the formatting and the way a study is designed so it does not elicit some bias in the result. Okay, next is voluntary response sampling, which consists of people who choose themselves by responding to a general appeal. So you might say, I might ask for a poll of readers or users, and you create a website and you have them respond. Instead of you selecting individuals, they're self-selecting. So you may end up with some skew in the data based on the fact that you have groups of people who might be disproportionately in favor or against something that you're testing, or show some consistency of results just because those are the same type of people who would volunteer for that response. So voluntary response sampling creates some skew or some bad sampling, potentially bad sampling data. All right, so we're going to talk about an example. CNN commentator Lou Dobbs does not like illegal immigration. So on one of his shows, he attacked a proposal to issue driver's licenses to illegal immigrants. Mr. Dobbs invited his viewers to go to his site to cast their opinions on the following. Would you be more or less likely to vote for a presidential candidate who supports giving driver's licenses to illegal immigrants? And out of the 7,350 people who voted, 97% said less likely. All right, so we have a problem with this because it's a voluntary response sample. And by the way, you're selecting from a non-random population. Really, you're selecting from people who typically would have Lou Dobbs' biased views of illegal immigration. So you have two issues going on. One is the people that you're sampling, and two is the method of the sampling done. The second is with respect to what we just talked about, the voluntary response sampling, where you're getting people who are probably a little bit more agitated about the issue and then responding accordingly. So I would say that this number is relatively high for that particular response. Okay, so this brings us, actually we're going to do this additional classwork in class. We're going to move on and we're going to talk about other sampling methods and how to sample well. All right, so I have to move this around here. So simple random samples of size n individuals from a population chosen in a way such that every set of n individuals has an equal chance to be in the sample actually selected. Right, so this is, we're selecting an n number of people, and those n number of people have an equal chance to be in the sample as everybody else. So we call that a simple random sample. So let's say we have 1,000 people, that we just randomly pick 50 people. So each individual has the same likelihood of being chosen as all the other people in the survey. All right. So sometimes we're going to use a table of random digits, and that table is just a random, kind of like a random number generator. We have that in table D in the book. And so each entry is equally likely to be any one of the 10 digits, and there's a sequence for using this table. We can also use a random number generator. It might be a little bit easier to do. But the table here is kind of outdated but current method, or going out the door method of small random sampling. So for larger numbers, we probably wouldn't want to use this table. But you can reference it in the back of the book in table D. All right, so let's talk about stratified random samples. So stratified random sample and strata. So we're first going to classify the population to similar individuals, or strata, or groups of individuals. Then we're going to choose, so similar meaning not between the groups, but similar meaning within a given group. And then we're going to sample from, we're going to take a simple random sample from each of those groups. So in order to make sure that we get a representation from each of these groups, we're going to separate them out. Because a general random sample, just by the way that it's handled, sometimes might end up having more sampling done in a specific category. In order to eliminate that skew in randomization, which sometimes is not so random in a way, we're going to stratify the population, and then we're going to sample from each of those segments of the population to make sure that we have each of the segments of the population where it's relevant, appropriately represented. All right, so this is a stratified random sample. All right, so this is an example of a stratified random sample. There's a little bit of reading here, so you might want to pause it, but basically radio station that broadcasts a piece of music owes a royalty to the composer. And so this organization of composers called ASCAP collects the royalties for all of its members by charging stations a license fee for the right to play member songs. ASCAP has 4 million songs in its catalog and collects $435 million in fees each year. So ASCAP is trying to distribute this income among its members. And so what they're going to do is they're going to stratify by community, metropolitan and rural, geographic location, and then the size of the license fee paid, and then distribute from there. So this is a way to stratify to make sure that you're representing each of the different communities appropriately. And so you can read this a little bit more if you want. But basically, this is just an example of how to stratify in order to find particular groups that are unique, and then to make sure that you're representing those unique groups appropriately as part of the survey. All right, so the next is called a cluster, sample cluster surveys. And so what you're going to do is you're going to find a cluster that's representative of your entire population. So let's say I have 5 clusters of groups of people. I have Fremont, Homestead, Lynbrook, Monte Vista, and Cupertino. And I know that, let's just say that they're all coming from the same population. I know that the representation is different for each of them, but we'll pretend that it's not, and that the each of the schools is equally heterogeneous. All right. And so what we can do then, instead of taking a survey of each of the schools, we can just sample data from one of the schools. And so the cluster survey is going to make it a little bit easier for us to sample than a stratified survey and still get a relatively decent set of information, assuming that you can find data clusters that are equally heterogeneous as the other clusters are. Right, so let's take a look at stratified random sampling versus cluster. So stratified random sampling, we're going to stratify the population sample from each strata. It's more precise and granular. You avoid some of the complications that you get with just simple random sampling because there might be some skew towards different groups with a simple random sampling. It is a challenge to do this with large numbers, or if the spread of the sample is wide geographically. It is more time consuming, or also if there's many categories. Cluster, on the other hand, we're going to find clusters of people that represent the population. We're going to sample these clusters. It's simpler and can be less precise, but not necessarily. It's easier for evaluating larger populations, and it's less time consuming. All right, so let's take a look at an example here. We have a manager at a beachfront hotel who wants to survey guests in the hotel to estimate overall customer satisfaction. The hotel has 2 towers, an older one south and a newer one north. Each tower has 10 floors of standard rooms and 2 floors of suites. It's 880 rooms. So we want to explain how to select a simple random survey of 88 rooms, explain how to select stratified random sample, and then explain why selecting 2 out of 24 floors is a bad idea. So you can think about this. I'm going to go on to the answer. All right, so the way that I set this up was for the first selection, I'm going to number each of the rooms from 1 to 880. I'm going to use a random number generator to select 88 unique rooms. So this is a simple random sample. Second is a stratified random sample. So I'm going to stratify by tower type and direction, and then select there are 200 of each. I'm going to select 20 of 200 for each. And then finally, I'm going to explain that if we were to select 2 out of 24 floors, it's a bad idea because the floors are homogeneous. So we're trying to, and this is an attempt at doing a cluster sample, because the floors are not equally heterogeneous and they're homogeneous. It would be difficult to get that full sampling of the different types of people that would be in each of the different rooms. All right, so we're going to move on for your classwork, and then we're going to pause and continue and finish the video. All right, so the student council wants to conduct a survey. So this is your classwork, second classwork. So student council wants to conduct a survey during the first 5 minutes of a school assembly about the school library. Describe how you would use each of these methods to select 80 students to complete the survey. Simple random sample, stratified random sample, and a cluster sample. All right, that's it for now. You want to pause here, write this down, and we'll come back at you and continue this lesson.